Hello, gentlemen. Welcome back. Hopefully, you guys did a good job with the substitution method. That's something that should have been somewhat familiar to you, and hopefully, you just that review we did in the last video was helpful, and you picked it up rather quickly. The purpose of this video is to look at another technique called elimination. Again, I think you guys should have this should be a review for you guys. So hopefully you pick it up quickly. I'm going to do 3 examples of elimination, increasing difficulty. We're going to start actually this video with a word problem, again, just to get you guys thinking along the lines of reading, interpreting information, and then using some of these techniques to solve problems. Then we'll do 3 examples of elimination, and then I'll give you some more practice problems. Okay, so let's get started. So a small fast food restaurant invests $5,000 to produce a new food item that will sell for $3.49. The cost to produce each item is $2.16. How many items must be sold in order to break even? Now, break even means that the amount of money that I invest is equal to the amount of money I bring in. Okay, so essentially your profit is equal to zero. So your cost is equal to your revenue. So first thing that we want to do is to see what the cost of bringing in this new food is. And it's all going to depend upon the number of items that we produce. So let's let X be the number of items that we produce. Okay? And then the cost of producing X items is going to be the original $5,000 plus X times $2.16 per item. All right, so here's my cost function. Cost is basically that 5,000 we started with, plus for each item it's going to cost me $2.16. Our revenue is how much money are we going to bring in. All right, so if we produce this many, if we produce X items of new food, how much will I bring in for that? And that's going to be $3.49 times X. Okay, 2 ways to go from here. Break even is going to either look at your profit function. Both will produce the same thing. I can either set these two equal to each other right here. If I set those two equal to each other, that will help me find the break-even point. Or I can say that my profit function is equal to revenue minus cost, which will give me this function right here. Okay? And then if what I'm going to do is, okay, if I'm looking for my break-even cost, my break-even number to produce, I would set my profit equal to 0. Okay? And then again, I have an equation of one unknown. This is the simplest way, I would say. Setting these two equal to each other, or setting the profit equal to 0. If I do that, and I can simplify, I'm going to get 3760 units. Okay? If I look at it graphically, here's my profit function right here. Here's my break-even point. Beyond this, I will make a profit. If I produce less than that, I will not make enough money to counteract what I've already spent. Okay? And again, you should see that's a linear function. Obviously, this is not overly realistic because profit's not going to continue. There's going to be a point in which it's got to turn around. All right? Let's look at the elimination method of solving a system of 2 linear equations. Basically, what you want to do is you want to obtain coefficients that differ only by sign, either for the x unknown or the y unknown. Okay. Once I produce that, now there's different ways that I have to produce that. I got to multiply either one or both of the equations by some number to make that happen. But once I get the coefficients to differ only by sign, then I can add the 2 equations. That will eliminate one of the variables. Once I eliminate one of the variables, I can solve for the other, and then again go back and do back substitution to solve for the first variable. Again, sounds complicated, really isn't. Let's do some examples to show you how to go about this. This is a pretty straightforward one. The reason why this one's straightforward is because I already have coefficients here for y that differ only by sign. Okay, so in this particular example, I can simply add 1 and 2. All right, if I add 1 and 2, what I'm going to get is 5x is equal to 15. All right, because the minus 5y and the plus 5y cancel each other out. At this point, I would divide by 5 and get x is equal to 3. Once I have x is equal to 3, I need to back substitute to solve for y. What that means is plug 3 into either one of these equations. It doesn't matter. And then solve for y. I'll plug it into the first one. I get 3 times 3 minus 5y is equal to 2. And y is going to be equal to 7/5. Okay, so if I bring that 9 across, I'm going to get negative 7 divided by negative 5, and I'll get 7/5. Then I can check my solutions. If I plug them in, you'll see that it works. And we have the point 3 comma 7/5 is a solution to that system of equations. Okay? Again, these are linear equations, and they're going to intersect at one point, and that's the point at which they're going to intersect. This one's a little bit more detailed because of the fact that I don't have the same coefficients in either case. So I have to multiply one of these or both of these by some numbers to make it work. My advice here is to look at this first equation. All right, if I multiply the top equation by negative 3, then I'll have the coefficients for x will differ only by sign. Okay, so I'd only have to multiply the first one by negative 3. If I do that, this is what I get. I get negative 3x minus 21y equals negative 36. Make sure at this point that you're multiplying by the entire equation by negative 3, not just the x term. It has to be the entire equation. And what you do to one side, you have to do to the other. By doing that, I'm not changing the integrity of the equation. It's still the same equation. Okay? What I now want to do is add this new equation, to the second one. Okay? And again, what you should see is that the 3x and the negative 3x are going to cancel each other out. I'm left with negative 26y is equal to negative 26, or y is equal to 1. And again, what I'm going to do is I'm going to back substitute to solve for x, and I do that by plugging this y value into either one of these equations. Again, it doesn't matter. Pick the one that's going to be most simple. I would pick the first one, and the reason, because then I don't have to do any division. I can simply solve for x. And actually, I made it more difficult here. And I'll get x is equal to 5. Okay, again, I want to check and see that works for both. And so my solution is going to be 5, 1. That's going to be the intersection point between those two linear equations. This one is a little bit more complicated simply because I have to multiply both equations by some number in order to do elimination. Okay, because I can't multiply one of them by an integer that will give me the other one. So what I would recommend here is looking at the x ones because I got smaller numbers. Also, I have opposite signs. I have opposite signs here too, but I'd have to multiply this bottom one by 11 and the top one by 5. I'm dealing with bigger numbers. So my preference here would be to multiply the top one by 2 and the bottom one by 3. Okay? So let's do that. Let's multiply 1 by 2 and the second equation by 3. If I do that, my top equation becomes 6x plus 22y is equal to 8. And the second equation becomes negative 6x minus 15y is equal to 27. At this point, I can now add them. These are still the same equations. I haven't changed the integrity of either one of them because I multiplied both sides by the same number. If I simply add those two equations now, the x term is going to cancel off, and I'm going to be left with 7y is equal to 35. Divide by 7, I get 5. Again, back substitute to solve for x. Plug it in, I'm using the first one. So 3x plus 11 times 5 is equal to 4. If I solve that, I'm going to get negative 17. And again, I would check my solutions and see that negative 17 to 5 is a solution to this system of equations. Okay, so here's another method. Could I have used substitution? In some situations, substitution is easier. In other situations, elimination is easier. For this particular problem, elimination is clearly easier because I'm not dealing with fractions or anything of that nature. All right, so here's an introduction to elimination. We're going to do some more practice in the next couple videos with both substitution and elimination and trying to figure out which method it makes more sense. All right, make sure you guys are doing the practice problems. If you have some questions on the elimination method, make sure you're asking me. All right, here's some reading I want you to do. Here's some examples to look at. and some problems that will help reinforce this idea. Some of them will be really basic, others will require a little bit more thought. All right? Any questions, email me. Make sure you attend Google Hangouts, and then we'll get ready for the next video. Okay, fellas? Have a good day.